Good morning. My name is Trobradovic from SDT Ultrasound Solutions team, and today I will be talking to you about connecting the reliability dots, including more technologies into modern condition monitoring and approach with and instead of versus. A little bit of medicine to start with, just to take some nice comparison and put a different light on condition monitoring. Because in our private life we do care about medicine a lot, so we care about our health. Now imagine a doctor using one single diagnostic method, let's say X-rays. That's quite usual and simple. So X-ray examination is a good method, there's no doubt about it. It's verified, precise, reliable, so there is no doubt that it's a method to be used in medicine. And there one day you come with a headache and doctor says, let's do the X-rays. Of course, he will detect nothing and conclusion will be, you are fine. Nothing detected, everything is okay. Well, imagine that 1 month later you come with a rash on your hand and he does the X-rays again. Of course, the conclusion will be that you are fine and nothing is detected. And maybe 2 weeks later you feel dizzy with fever and you come to the same doctor and he says, let's do it again, let's do the X-rays. And conclusion will be, of course, the same, that you are fine and nothing was detected in that time. Now you see where this is going, so I don't need to continue with more examples, but obviously, can we say that this doctor is bad at X-rays because he's not finding what's the problem with you? Certainly not, because he's obviously very good at it. Doing the same thing continuously all the time, he probably drove it to the perfection. But the question is, would you choose that doctor to be the one to take care about your health? Personally, I wouldn't, so I don't think that you would also. Now, humans consist of really a lot of parts. Let's call them parts now, and they often operate in a completely different ways. Just imagine blood, bones, and muscles, three different kinds of elements of your body. They function in a completely different way. So not only do they function in a different way, they have different failure modes. Different bad things can happen to them. So human body as a system with its all thousands of components may face many different failure modes. So God forbid you can break your leg, or you can have your hair falling off. These are completely two different failure modes. And they will, of course, give you completely different symptoms at different stages. So the question now, very practical from a private life, what doctor would you choose? Using what criteria? Now, I would definitely sit and think which doctor to choose. So I would like to have a doctor who understands diversity of the illnesses, because there are so many things that can happen. That will be my first criteria. My second criteria, definitely, which drives naturally from the first one, is doctor who understands diversity of the symptoms. Because only with the symptoms you can find a problem. And finally, a doctor who understands different stages. And I assume that if he understands the illness, understands the symptom and different stages, well, I assume he can pretty much with a high certainty find what is the problem. And of course I expect that he will have approach to your diagnostic in a clever way. So obviously connect illness to symptom to method. That means I know what might be the problem, this would be the symptom, and this is the way I can find it. Then choose the set of methods that will cover all suspected, let's call them failures in a human case. Choose the method according to the detectability. In which stage you can find a problem. Well, that comes quite important when we talk about our health. And then, of course, we need to be very practical. Let's choose the least invasive and the safest method. And that's quite important when we talk about diagnostic in medicine. Now, this sounds definitely much better than the guy with only X-rays, and probably much more successful. Whatever I told now, I'm not discovering anything new for you here. This is something that you know from your private life, and this is exactly how medicine works. And this is what you expect as a patient. This is what I expect as a patient when I go to the doctor. And this is actually why we are so good in saving lives in 21st century. Medicine has developed tremendously. And one of the issues is diagnostic, definitely. Now, when you see this, what we discussed about medicine, this is condition monitoring in its best form. Those are the rules that we try to apply in our industrial condition monitoring. Absolutely the same. It's a copy-paste rules. Now, if you think about a pump instead of a human body, the system, again, think of it as an organism. And that organism has a lot of components: motor, coupling, pump, valve, seal, all of them. So there are several components, and then you can break it down to subcomponents, to the non-repairable items. And you will see you have a huge number of organs in this organism. And then we need to think about all different failure modes within that pump and its subcomponents and components. Think about the symptom of each failure mode. So what can go wrong and what will be the symptom of that possible problem? Now, when we come to the level of thinking about symptoms, there are so many varieties, because think about symptoms that are same for different failures. Just like in the human body. You can have a high fever, but for many different reasons. Then you have to think about the symptoms that are unique for one single failure. That's quite easy. If you have that symptoms, you know what's the problem. Think about the different symptoms at different stages. So the same failure at the different stages will give you different symptoms. Think about the symptom of a consequence and, of course, symptom of a cause. Because we can have a combination of symptoms. Some of them are talking about a consequence and some of them are actually talking about a cause, if at that stage. So I'm sure we can all agree about this huge and similarity between reliability and medicine. Because what we are trying to do in industry is to apply medicine to our assets. And what we are trying to do in medicine actually to have reliable life. So the only difference is that we have a different patient. Jokingly, you can say that medicine might be a little bit easier because humans do talk. So when you come to the doctor, you usually say, what is the problem? I asked gearboxes many times, what's the problem? They don't speak. So it could be a little bit more difficult. Now, you remember from the beginning, doctor with x-rays only. He wouldn't be very successful in the modern medicine. Definitely. He wouldn't have much patience. Now, how can anyone think then in reliability, in condition monitoring in industry, that we can monitor asset with one single technology? Maybe two. Okay, let's say two. That's very strange and very brave, thinking that we can cover all failure modes, all symptoms that these failure modes will give us, and be absolutely sure that we can put a signature on that report that everything is okay or something is not okay. Quite strange and quite brave. But still today we hear statements like, I can do it all, my technology is the best, this is the my favorite definitely, and me too. So whatever you can find, I can find it too. Now, these statements are normally given very confidently and with a very, very firm voice. But what you can see behind that facade of confidence and that firm voice, you can see or you can hear that it sounds very, very defensive. Very often that means defending its own position. So very often the condition monitoring people, some of them will defend their own position with this, or simply resisting any kind of change, because there are many people who really like their comfort zone. Don't make waves, everything is fine. Also, there is an element of fear, which is absolutely human. It's not unique for the condition monitoring and reliability people. It's a fear of new. Well, in my personal opinion, there shouldn't be a fear of new. The absence of new is the actual problem. Fear of different, again, quite irrational, because differences are bringing improvement. And the fear of competition, which is absolutely irrational, because try to imagine that you have a goalkeeper joining a team, and then the midfield player and a coach see him as a competition. It's not a competition. It's a player who plays a different position. and it can only make your team much better. Now, saying all these famous sentences, I can do it all, I'm the best, and me too, creates a versus approach instead of and approach. This versus approach means that suddenly somebody's trying to create a competition between technologies. Now, it ends up as a vibration versus ultrasound, thermography versus ultrasound, oil analysis versus vibration. And it doesn't really make much sense thinking about that, because versus, word versus very often means conflict. Conflict normally means casualties. And in this case, casualties are our assets within our company or our client's company. Casualties is benefit of our company or our business. And in the end, we become casualties of that approach, because there's no company, there's no work. So we need to look at it quite simple. Several useful rules that can be applied to create and instead of versus is very basic and simple question. Is condition monitoring needed? Is needed at all? Now, answer lies in RCM, definitely. We need to go for RCM and understand, do we need to do condition monitoring on this asset or not? Criticality analysis, failure mode effect analysis, all these issues, I will not dwell too much about that because there's not enough time. But the fundament, the essence is, if it doesn't bring any benefit, it shouldn't be done at all. It's not like condition monitoring as an approach is a carved in stone. Yes, it will help you in 70–80% of the cases, but not in 100. So it shouldn't be done just because we have to do it. No, if it doesn't bring benefit, simply don't do it. It makes no sense. It's just a cost in that case. Another useful rule might be the question, what kind of condition monitoring I need? So the answers are lying in understanding the system, definitely. Understanding the whole system environment and each asset, understanding the failure modes of that asset, understanding the symptoms that will be generated by a certain failure mode. Now, this defines what technology you need. There are, of course, some other parameters, we'll talk about it later, but what the system does, what each asset in that system is delivering as a function, what is the failure mode, and what will be the symptoms. And that is exactly pointing you to what technology you need to use. So obviously, understanding these 3 or 4 fundamental questions, obviously there is no best technology, because it cannot be. There is a best technology for certain failure modes. I absolutely agree, and we have to be very, very precise about that. There is a best technology for a certain failure mode. There is a best combination of technologies for a certain system or certain profile of the company or production. But they are all equally valuable. You can think about it as a joke, but even a nose that everyone has is a very valuable condition monitoring technology. Why not? We shouldn't laugh at that. Years ago, we had people walking around with the screwdrivers and listening to the bearings. Well, that's what they had at that time. But is it bad? No. It's still much better than nothing. At least they care. Now, also very important is that a definition of condition monitoring is quite often a misconception that put this versus approach. Because being in charge of condition monitoring means, by definition, determining the condition of the asset and its ability to perform. But that includes all. That doesn't include just the parts that rotate. That doesn't include just the fancy stuff. That's mechanical, electrical, valves, absolutely everything. So need for multi-technology approach is, knowing this, quite self-explanatory. Because doing just the fancy things or things I can do doesn't necessarily mean that that is enough. So the rule number 1 should be the need of the asset. Now back to something that is considered fundamental with and pretty much correct, considered fundamental. It's the IPF curve. So the IPF curve explains us, at least gives us a very nice picture about how asset life, life cycle should go and what really happens. So we have a design, installation, operation where we do some precision and proactive maintenance, then we have predictive, preventive, and then we have, boom, we have a problem. So that's the end of life of the asset. So if we do all things properly in this PF curve, if we understand it as an approach, it is really helpful, and we should all look at it quite as often as we can. But many curves also contain technologies in this picture, and those technologies are placed by stage, by detection stage, suggesting that this is before and this is after. Now, I got a feeling very often that this actually creates this versus approach. This is before, this is better, my technology is better than yours, which is quite incorrect. Because when you look at the DIPF curve with the technologies placed in as a function of time, you can see that certain technologies are coming much before and certain technologies are much later, which is correct in some cases, but it really requires some deeper thoughts because it can be very, very much misleading. And usually it creates a conflict and unnecessary discussion because there is no one curve that fits all. No matter how many times you publish one curve, it doesn't make it correct for all the assets. It's a nice example, it's an interesting information, but not more than that. Now here in this one, ultrasound is the earliest sign. Now knowing that I'm coming from the ultrasound world, I would be very happy to make this tattoo on my forehead and talk about this DIPF curve only, because it will be quite interesting sales argument. But it's not the case, because in some others there's vibration depending who is publishing it. Then in others there is an oil analysis. So which one is correct and which one is not correct? And then you can usually see people sitting and discussing it and basically creating a conflict versus this versus that, which is completely irrational, to be honest. What this curve doesn't say is what machine it applies to. Because there's no explanation in this curve that this is for the pump, this is for the turbine, this is for the electrical cabinet. It doesn't say that. So it obviously doesn't say what failure mode it applies to. So we can only look at it as an interesting picture, but not as a rule. So I hope you understand the possible trap that we can all fall into if we just follow this as a carved in stone. Because each of this a DIPF curve with technologies placed as a function of time, each of them is both correct and incorrect. It all depends about the failure mode. So this one makes a lot of sense for bearings, lubrication, cavitation, gears, valves, hydraulics, some electrical, absolutely correct. But does it make sense for unbalanced resonance misalignment? Not so much, because then the sequence of the technologies should be changed. We should definitely have vibration first and then everybody else. Now, does it make sense for detecting varnish? Absolutely not. Because we cannot have a curve explaining detection of varnish and oil analysis put in a place number 3. So it doesn't make sense. So what I'm trying to appeal to all of you is that does curve with vibration on the first place make sense for all assets and all failure modes? Not. One with oil analysis? Of course not. With the thermography at the first place? Same answer. Because there is an information missing. What failure mode are we talking about? What asset are we talking about? So all of them can be wrong and correct in the same time. It's definitely important every time you see the DIPF curve to observe it with the failure modes in mind. Each different asset or each different failure mode should have a separate DIPF curve. There is no one that fits all the problems of all the assets in the world. It's simply not correct. Now, if we want to look at DIPF curve with technologies placed in time, which might be quite useful, be careful what you choose. Be careful and always ask about the failure mode. What is your failure mode? So how many technologies we need? As a conclusion out of this, which one is the earliest detection? Which one is the best? So those are the questions, especially when companies are actually establishing condition monitoring team and say, okay, let's see what should we do first. And of course, the question is always, which one is the best? We will invest in that one, and we will train people in that one. So by looking at the IPF curve, the failure mode is something that needs to be there. Considering the fact that nobody can publish 3 zillion of different DIPF curves, you need to take a look at them and think about your failure mode, think about the symptom your failure mode is generating, and then put the technology on place number 1, 2, 3, 4, 5, or whatever. Which one will detect the earliest? And earliest detection is not always necessarily the biggest criteria. Sometimes the earliest detection is extremely expensive, much more expensive than the failure itself, or it's not safe to do, or it's invasive. So there are several factors that needs to be observed properly to do it correctly. Now, using just some of the technologies, it's definitely leading us to certain situations we can find ourselves in. So covering just some of the failure modes. So if we are using just some of the technologies, you are covering just some of the failure modes. So if you are lucky, your machine will fail in that way. If you're not lucky, well, that's life. You will not be able to find those. If you are using just one technology, you cannot be early in all covered failure modes. In some of them, you might be quite late. So in other words, it's not very easy to be successful in condition monitoring by using one or two technologies only. So it's quite clear for what I explained right now that versus doesn't work, and it's completely irrational, and it's a wrong approach, because there is no versus, there is no competitors here. They are all members of the team working to the same goal, and works, and always works. When technologies and people using them cooperate, they will much easier achieve desired success. Now, being vibration analyst and having ultrasound on your team, it definitely makes you better and more successful. Being ultrasound and having infrared on your team, again, makes you better and successful. If you are all of the above, and then you have a new team member with oil analysis, you're getting better and better. So all these new technologies and diversity should be always absolutely welcomed, never looked at as a competitor, because it's irrational. And of course, this works for absolutely all technologies. It's not only for the big 5 or big 3. So what technology you need? Again, simple rule. Look at your failure modes and symptoms. What is your failure mode? What symptom will it generate? You need to find a symptom. Look at the detectability. Try to be early. If it makes sense, considering cost, safety, and all this stuff, usually it's okay. Look at the criticality of the asset. Look at the failure history and the root causes. So does this asset usually normally fails in this way, and what is the root cause? And what that root cause is generating as a symptom. So that would be a good way to look at it, to choose the technology. And there is, of course, many more data you should collect and look at very carefully before deciding what technology to use on each different failure mode. But of course, there is another aspect often forgotten, but it's a pain point of all condition monitoring teams in the world. These are your resources, your human resources. Sometimes financial resources, but also human resources are quite important, because to do proper condition monitoring, we need time. Time is probably the most important and most valuable asset. So if anyone running a company or condition monitoring team wants his people to improve, he needs to give them time to do that. No time, no improvement. Now, how many people you have? How many of them are actually involved in condition monitoring? And not only that, how many of them are fully qualified to do that condition monitoring? How many of them were invested in with the proper training? Now, this is a topic to discuss because there's never enough people. And I know that from my own experience, and I'm sure all of you know that you will never have enough people. That's simply a fact. And of course, let's be honest, and it's not likely you will get more people. So just the fact that you don't have enough people to perform the task in front of you, and you can go up to the management and say, I need 3 more guys. It's not really likely that you will get those 3 guys. So let's see what we can do with existing resources. Because with limited number of people, normally you need to limit number of monitored assets because there is as much as you can do. You need to limit number of technologies again. The same thing like in point number 1. You do not have enough time to investigate, and this is really painful. This is really painful because finding a proper data that will lead you to proper conclusion and not having time to investigate, to find the root cause and improve, that's really a sin. It's so much wasted data because we need to find the root cause and to remove it to improve. Condition monitoring by itself doesn't actually improve reliability, but it's giving us the information, the critical information that you must have if you want to improve your reliability. But just collecting that information is simply not enough. So I call it a curse of being good at CM, because if you are bad at CM, and if you are lucky, you will keep a low profile for 25 years and then you will retire and everybody happy. If you are really good at CM, there will be a lot of spotlight on you. And sometimes it can get you in trouble. Now, first option is if you don't have enough resources, you limit number of assets based on criticality analysis and you compare it with available time and human resources you have, and then you choose what to monitor. Other assets are left out. Of course, we call them non-critical assets, but every asset is important. It's not necessarily critical, but it's important. And every failure creates certain cost. Of course, then you will stretch your time over those assets you choose, trying to plan time per asset. And this is quite strange. That this is a practice you normally done. You plan time per asset. I have 1,000 assets. I have 100 hours. So this is the amount of time I can spend on each asset. Now, what I learned over the years that planning analysis and investigation is not possible. It's simply not possible. I have seen so many people try to do that, saying I will spend 25 minutes to make analysis of the data on this machine. And then I move to another one. You cannot plan that. It's an investigation. If you are lucky, you will find a problem on a planetary gearbox in 7 minutes. But that's if you're lucky. If you're not lucky, you will spend 2 weeks. Nobody can plan that. It's an investigation. So trying to plan time per asset, it's usually getting us in trouble because we just say, okay, something smells bad in this asset, but I don't have time to continue investigating. That's quite bad. Now, what you end up doing is actually scratching the surface. No time to investigate root causes. That definitely means no improvement. Then actually no time to use your entire knowledge. And that's quite painful. All those years of training, education, and knowledge, and reading and learning, and then you don't have enough time to investigate. You don't have enough time to dive deep into the problem, to use actually that knowledge. Using 10 or 15% of your knowledge, it's not a win-win combination, definitely. Not for you, not for the company. And there is a result. That kind of condition monitoring is usually ineffective, and people burn out of frustration. We have all seen it many times because you are doing the same thing over and over again with the same outcome, and sooner or later you get burned out of frustration. The second option is that you stretch yourself and your team over the limits. Many people do that. At least they try for some time. So you work 25 hours a day, so to speak. Usually it's a juggling like an artist. We have all seen it many times. Trying to be at 3 places at the same time. And let's say you succeed. There's a lot of sweat and tears, and there's a lot of pain, a lot of incredibly hard work, and you succeed. With that existing resources, you make miracles, you heavily improve reliability, you are able to find all the problems, everybody happy. And again, then you get a great congratulations, you are a hero, the spotlight is on you, and then it comes to the curse of being good at condition monitoring. Considering that you perform so good, your boss, your management will normally tell you that this is working really fantastic. Let's cover more assets. Let's cover more failure modes. Let's find all root causes and remove them. Because you're doing it so good and the result is absolutely fantastic. So let's get more of that. And of course, you are smiling, they are smiling, everybody is happy. It all goes in a good direction, but there is always a small print. And that small print says, you need to do all of that with the same resources. Of course, when somebody is congratulating to you and calling you a hero, you don't read the small prints. That happens a few days later. So, and again, it's a fact. There's no point in crying over that. It's just a fact. But you can easily get yourself in lose-lose situation. You lose, company loses. Decrease of reliability, decrease of profit, and we know how it ends. The company goes down, and nobody wants that. Now, this is the reality of our resources, this small pyramid. You have a small number, just the tip of the iceberg of the specialists, people who are highly trained in a certain condition monitoring technologies. Then you have entire team, which is around you, and that's a little bit more people, but not necessarily highly trained in a certain technology. And then you have an army of operators. And the problem we have here is that those who know have no time, because you have a small number of specialists, and that's exactly that much they can do. They cannot work 5 hours a day. So those who know have no time, and those who have time, and they can actually spare a few minutes a day or an hour a week, they don't know. So they cannot help you. And this is something we need to change, and we are changing it rapidly over last few years. If we turn the pyramid upside down, then we will definitely give more time to specialists to focus and dive deep on certain problems. All the guys, entire team or girls, can do a lot of fantastic work. Data collection, some binary diagnostic conclusions, because sometimes the problem is simple, yes or no. Condition-based lubrication, actually they can be nurses for the doctors, making a triage. And then down at the bottom, energy saving program, data collection, operator-driven reliability. There are huge resources in these two groups that are formally out of condition monitoring, but we have to join them in. Now, in this case, those who know have more time, and they can use that time to actually bring the benefit. And that all happens because those who have time now know how to be useful, how to do certain jobs. Now, obviously, we need to distribute certain tasks down the pyramid. It's called operator-driven reliability, ODR. And relatively simple, but still extremely valuable tasks. Very often those are immediate conclusions, yes or no, good or bad, especially with people who have a lot of experience with this certain asset because they're operating it. But then again, they are also collecting data for you as a condition monitoring specialist. It's just like a triage in hospital. So the nurse will be the best triage, because she will say good, bad. This is urgent, this needs to go immediately to the doctor. Now, of course, that's all possible only in case that you give them technology they can use. Because it needs to be simple and clear for them, absolutely, because you cannot turn the operator into the condition monitoring engineer. Not because that's a bad idea, everybody deserves a chance. But the problem is that then, in that case, you don't have the operator. So you just need to give them additional tasks without putting too much burden on them. Now, of course, they need to be able to perform complex tasks for you. So that means they can test something and have a fast conclusion, good or bad. Is it critical? Should I call immediately condition monitoring or not? That's quite enough, but also collecting the data for you. And then you can use that data for much more complex tasks. Now, it's not a new idea, of course, we know that. Operator-driven reliability has been with us for years, but it cannot be done with every technology. So we have many names for that: autonomous maintenance, operator-driven reliability, or whatever, and then we give simple tasks. We say, check the pump. Well, what does it mean, check the pump? What, is the pump there? Yeah, pump is there. Check the pressure gauge, check this, check that. That's all fine, but we can put certain technology in the hands of those people and make them really very successful and useful. It cannot be done with every technology because, as an example, with vibration analysis is quite difficult. It's a specialist only. Oil analysis also quite difficult, specialists only. Not even taking the samples, taking the oil samples is really important job. It's actually essential for the good analysis. With infrared, to the certain level, yes, we can do it, but not really deep. With ultrasound is interesting technology because it's both for specialists and non-specialists. It's simple when you want, it's complex when you need. And it's nothing about being better, because for the last half an hour I was talking about nothing is better, everything is equally valuable. So talking about ultrasound this way doesn't really mean it's better, and I'm not even trying to say that. It's simply about the nature of applications that ultrasound covers. Leak detection, very simple, easy to push to operator-driven reliability. Valves, very easy to push down. Tightness, hydraulics, cavitation testing, very easy to push down. Primary rotating assets monitoring. The first line of defense in rotating assets monitoring. In our bearings, very easy to push to operator-driven reliability. Lubrication plus condition monitoring as a team, easy to push to lube team, because lube team is not necessarily, and usually it's not, part of the condition monitoring. Now they can become part of condition monitoring team, not maybe officially, but contributing a lot. Now when you look at the applications of ultrasound in industry, you can see that there is a huge number of reasons why we can actually put it down to operator-driven reliability. Because we don't need highly trained condition monitoring engineer to check 200 valves on the machine that is very specific, because the operator working on that machine is maybe the best person to test it and collect data for the condition monitoring engineer to look later. And of course, we always speak about this holistic approach, that for each asset, I need multi-technologies. And from what I said until now, it's quite self-explanatory. Because if I want to cover all the failure modes, I need to be able to use multi-technology. I put 5 of them here, but nothing stops us to have 10. From detecting a problem, so the first stage should be, is it okay or not? From detecting a problem, is it okay and is there a problem? So does it sound fine or it sounds critical? Is alarm triggered or not? That's something we can push down to operator-driven reliability. Then we have a second stage through trending. Trending is not necessarily very complex, where you can see something being stable or going up and down. Maybe going down can be a problem, maybe going up is a problem, but everybody understands when something is stable, it sounds quite well. And then we can go down to analysis, time waveform, spectrum, or whatever, to the deep analysis. So there is a job for everyone in this pyramid, and we shouldn't be unfair and put everything on the shoulder of condition monitoring and then say, guys, you are not successful because you don't have enough time. That's not fair. But also we shouldn't overburden operators because they have their own job to do. So we just need to be very careful and put them certain tools in the hands that they will find very interesting and still do extremely valuable job. Now, if you go one step further and you add ultrasound guided lubrication in this strategy, that opens up a lot of time, but as a part of condition monitoring. Not the person who is going out and greasing bearings based on time, because he doesn't collect any useful data for you, and on top of that he's probably ruining the bearings. It's an additional topic for probably a few hours of discussion, but I will just try to touch it for the moment. To start with, if you have a proper lubrication and remove up to 60% of the problems that are rooted in lubrication, that completely changes a picture and working day for condition monitoring. Just imagine you remove 60% of the problems coming from one cause. Their job now becomes completely different. But not only that, what we have today, and very, very often, unfortunately too often, we have this ending up with this. And nobody knows what actually happens. And condition monitoring people should say something about this asset. Very difficult. Of course, it's an excellent excuse. It wasn't me, it was a formula. So don't ask me for any responsibility. But excuses are history. We don't work on excuses anymore. We are living in an age of data. Job must be done correctly. And not only that, it must bring the additional benefit to condition monitoring team, because we have to turn the pyramid upside down. We need to help condition monitoring people. Now, if you look at what strategy means, what does it mean to include lubrication in condition monitoring? That means data about each and every single process that happened. What happened? How much grease? What was the condition before? What was the condition after? What was the condition 6 months ago compared with the condition today? What is my graph telling you? What is your KPI? How does your KPI look like? What is the outcome of absolutely each time you touch the bearing? To start with, why did you put grease in the first place? Was it really needed? What was the outcome? This information is condition monitoring information, not necessarily only lubrication information. Because if you look at what a typical condition-based lubrication LubExpert strategist is looking at every day, you have complete ultrasound trending, you have behavior before and after lubrication, and you have outcome of each grease replenishment process. So pay attention to this part. This is complete ultrasound trending. So that means there are already people out there who are visiting those bearings anyway and collecting data. And there is a trend. So that means the data is already there. Now the only decision is, will somebody actually look at it from condition monitoring or not? Or vice versa, will lubrication team be so close to condition monitoring in organizational aspect to provide that data, which is critical, because that's the first line of defense. We can go further into that. There is a time waveform before and after grease replenishment. There is a spectrum before and after grease replenishment. So this is a dream for every condition monitoring engineer, that somebody is actually collecting all this beautiful data for you, let's be honest, completely free of charge, because these guys are doing it anyway. And not only that, but I have a data before and after lubrication. So in my analysis as a condition monitoring engineer, one thing is off my list. It's not lubrication, because I have data before and after. So that makes analysis of the data much more effective and much more efficient and faster. So this is definitely much more than lubrication excellence. This is condition monitoring data. It's there, and it should be included in condition monitoring. So again, multi-technology, multi-team, people with different talents, with different tasks, working together. That's how we can fight against the problem. We don't have enough people. We do have enough people. We just have to use them properly. Now, if you look at typical asset, and then you have maybe good. She's doing vibration analysis, highly trained. Then we have early bird, who is doing oil analysis, critical, highly trained. Then we have Saul Goodman, who's using infrared. Then we have a bartender who's doing ultrasound. And we have our their grease guy. So all these condition monitoring people are looking at the asset, observing. They're not creating condition. They are observing to conclude what the condition is. And then we have a guy coming with a grease gun who actually creates that condition. So we cannot keep him out of the condition monitoring team. We cannot keep him at the level of just the grease guy. Well, his name might be somebody, but his reliability role is critical because he should be doing condition-based lubrication and being highly trained. Not only because I'm a big fan of lubrication, but because people who observe condition need a cooperation with people who create condition. Otherwise, we are just wasting our resources, no matter how many technologies we use. So as you see from here, what I'm pointing at is a team of technologists, a team of people, different technologies, different people, different knowledge, different skill sets, and different expertise, and more people included in condition monitoring pyramid from top to shop floor, with all different knowledge and talents. It's not necessarily that everybody who uses technology need to be highly trained condition monitoring engineer. Everybody can contribute. So this is why we need multi-technologies to be able to filter it down to the pyramid, to cover all the failure modes, to cover all the symptoms, and to have optimized condition monitoring where we can do actually more with less. Now, success of a good condition monitoring program depends on a good condition monitoring people and organization, of course, but the definition should be, and it is measured by number of things that never happened. It's not easy, because we humans are not very good in noticing the absence of something. So it's much more easy to notice that there is a problem. But when there is not a problem, people don't notice that. So we need to remind them with a good reporting, with a proper reporting saying this didn't happen because we did our job properly. So we need to make sure that bad things don't happen. This is the end of my presentation for this time. I hope you enjoyed it, and let's do some question and answers. Thank you.